Hello. In this screencast, we're going to look at some of the features in P15. Specifically, we're going to dive into the sum values trend, which I've used to do some customizations to help set notifications for things that have more than one value. Whether it's, in one case, I'm going to show looking at AEEG, which is actually 5 different values calculated for that. Asymmetry spectrograms, we want to set notifications for that because symmetry shouldn't normally change during state changes, so we can use that to help notify us of changes in symmetry on a statistical basis. And we'll also look at electrode signal quality. These are all things that have multiple values that we may want to distill into a single value so that we can create a numeric display and a notification for that. This is Michael Guest, VP of Research and Clinical Applications for Persist. This is P15. It is a default configuration for the most part. I've done some customizations. For instance, I've taken my montages and I've put them into 1020 and 1010 and neonatal categories. You can do that as well. This is under montage groups. And if we split the screen for trends, this is a standard grouping, but you can create your own, and we'll look at a little bit of that as well as some other customizations for this. Right away, we can see we've probably got a bad electrode. Hard to tell in this case, but let's turn on the artifact reduction. Here we can see we've got a bad F8 that's flashing over on the electrode signal quality display over here. And of course, it's making a mess of the trends. So we turn on artifact reduction over here, and that tidies that up. So we've got a mixture of things happening. We've got a bad electrode at F8, and we've got physiological artifact. But we turn on the artifact reduction, and it largely moves that out of the way. We have our numeric panel over in the upper right here, showing that a seizure has been detected. If we click off of that, of course, that goes back to its normal display. And we have a couple of other displays. We have AEG amplitude and heart rate, because we've got our heart rate trend configured here. But what we can do to expand the utility of these? What if we wanted to set a notification or an indication on our numeric display when we have a number of channels, one or more channels go bad? Well, let's look at an example of that. But first, let's start with some customizations that have been done to the AEEG trends for neonatal. This is P15 running the neonatal seizure detector. And we can see that the seizure detector has lit up here. And so one of the things we can do with some values is we can extract values for amplitude integrated EEG and trend those a little differently. Let's go ahead and jump right to it. I'm going to click AEEG Analytics. Now this is a trend panel that we've created and customized. It's not part of the standard configuration in P15 for neonatal. And what we have here are some metrics taking values from the AEEG trend and distilling those into minimum and maximum, or maximum here. So we have AEEG left for a 1 minute running average, looking at the maximum value and the minimum value and trending that. So we can see that here. And if I right click over on this and do show values, we can see the values of the AEG averaged over a minute. And so the AEG is normally displayed in much higher resolution, much shorter epoch lengths, but you can see that this trend is thick. There's a max value and a min value. Even if we zoom in very close on the trends, let's take it from 2 hours, let's go to 1 minute. You can see some of these are thicker than others. So let's go forward a little bit to where we can see where some of these are more than a few pixels thick. It's because AEEG displays both the minimum and the maximum value by default. Now, Persist calculates max, min, median, 25 and 75% values, so you can display AEG or render it in different ways based on a number of different conventions. Let's go ahead and zoom back out to 2 hours on this. So since there's 5 values for each AEEG trend, and we want to time average those, we have to select which value we want, because if we average a time trend for AEEG, it'll just blur all of those together, and that's not very helpful. And we may want to do some other things. For instance, here we have AEEG for a 1 hour running average, and this is showing the 95th percentile of max and the 5th percentile of minimum. Well, why would we want to do that? The reason for that is you could have some outliers for any number of reasons. Artifact is a typical one. And averaging those in would give us maybe a less meaningful picture of what's happening with the amplitude. But by taking the 95th percentile of max and the 5th percentile of min, we get to smooth that out, make it a better representation of what's happening over that 1 hour running average. And here at the bottom, we're showing suppression ratio. We're not changing anything with that in this case. This is a default trend configuration. So how do we do that? Well, the time trend's pretty easy to figure out. Now, these are overlap trends. So if I click this one, you can see we have a trend title in there. The time trend is looking at the sum values output, and we're going to have a look at that in a moment. 0 to 0, that's the index, the first value, which is the max. Looking at the neonatal left hemisphere, we're going to average those values over 1 minute. Now, when we look at the trend that's overlapped here, if I double click on this, it says overlap previous because we want to put them into the same trend window because they're related to one another. They're both left hemisphere, but one's looking at min, one's looking at max. And this time when I go to the trend, we're looking at a sum values, 1 to 1, which is the index saying I want the second value in that. So 0 is the first, 1 is the second for AEG. So the first value is 0, index 0, that's the max. Second value is minimum, that's index 1. And I can actually pull up a little view here showing this is what the AEG is actually calculating and persist. We have max, then min, then median, then 75 and 25%. So max is index 0, min is index 1. So if I want the maximum and minimum, that's what I'll use is that index. We'll look at that in a moment. So let me cancel this. Now for these time trends, I'll click on that. This one's looking at 1 hour, so 3,600 seconds, and we're taking 95% of those because we have an ability to take different operators here. So this should be 95%. And then for the min, we'll take this other index value. So that's this trend, which is overlapped. Look at time. And this one should be 5%. And we're taking 1, which is the minimum value. And of course, we've given it a color, but the display is set to overlap the previous. So this is where we have that configured. Now, where do we get these values for this configuration? Let's go ahead and go to Preferences and Trend Preferences. And I'm going to go into the research mode of this to show the individual trends. And I'm just going to scroll down to sum values and see what is happening here. So this sum values trend, I could go ahead and create this trend. So you just go create. Under operations, we have sum values. So I created the sum values trend. And if we look at the setup for this, when we click this tab here, it's going to take the trend for AEG hemispheric, and this is looking at the left hemisphere. We also have a right hemisphere one, but we're going to take neo left hemisphere, and we're going to sum the values. Take the absolute, in other words, we don't want any negative values there. And I'm going to take an index, which means of those 5 values that are calculated for that, I want index 0, which happens to be the max. So that's the first one. Now if we look at the next one here, this is the same thing but for the right hemisphere. So we click the sum values trend title here, or the properties, and we click this little drop down, we can see that's set for neo right hemisphere. And again, same index 0 and 0. Now we want something to also grab just the minimum values for that, and that's what these are set up to do. So this is sum values, absolute, index is 1. So when I click the sum values trend here, this is set to just take index 1 values, which are the minimum. Because again, these are all dependent on what type of trend you're doing, but in AEG specifically, again, that's 0, 1, 2, 3, 4 index. So I'm going to move that notepad out of the way. So in a nutshell, we have the minimum values for left and right hemisphere and the maximum values for left and right hemisphere being taken. Now again, those have very short epoch lengths. So that's where the time trends come in. So when we go here to look at the analytics, that's where those are using those, but calculating them over different periods. So this, again, when I look at this, the time trend, it's using, this is the max, the average over 1 minute. And then when I look at the trend below that, time, it's using the 1-1, which is the minimum, and averaging it over a minute. And so those two are shown overlapped. So you can see the maximum value goes up pretty high during the seizure, and the minimum value increases as well. They're both going up, but this is that distance between those two values. And I can look at them at the cursor position. Right there is 48.8 microvolts, and the minimum is 21.9. And again, this is 95th percentile, and there's that 95% there. That's the 95th percentile of the maximum value. Again, you've got lots of different choices to pick from here. And then when we look at the trend it's overlapped with, there's the one down at the bottom showing the minimum value. You can see it's going up, changing much more slowly. We're averaging it with a 1 hour running average. Double click on that. It's overlapping that previous. It puts them together in that same window. And here's where we have the 5th percentile. Rather than average, standard deviation, min, max, we're taking that 5th percentile. Okay. So that's how we're creating this particular trend. Now you can see there's different choices there. We can pick, for that particular trend type, we can pick any one of these values, and then using a time trend, we can further refine that. So that's how we can get that sort of output. And again, I'll right click over on the right here. We can show the values at the cursor position, but we can also export these to CSV. So if I wanted to get these values out for CSV, I can hold down the Control or Shift key, highlight these. I'm just going to put the trend on for full screen. I go to Tools, and I can export channel and trend values to a CSV file. For the whole recording, if I didn't mark a range, or I can go ahead and mark a range by right-clicking, Insert Range. Tells me I've selected this number of seconds, and then I could just use the Tools, export channel trend values, and get it for that particular range as a CSV file. And it would just be one value for each one of those trends. Now, if I export the AEG, that's where you get 5 values for each epoch. All right, that's one example of what we can do with that. Now I'm going to shift to a different screen here. And this is showing Persist15 with a recording. That is a scalp EEG. It's the same one we started with, but we've done some customizations here. This is a point of the recording where we have a bad electrode. So if we go to Recorded Montage, and we change the gain here. Now recorded is all the channels to the amplifier reference. And so this is where we can find out if we have a bad electrode. Let's go to our other montages, and let's pick a bipolar longitudinal reference. So this is where we've got a bad F8 electrode. It's flashing here. You can see it's got lots of artifact going on. We're at 20 microvolts. Let's change that back down to 10. Let's split our screen so we can look at the trend display. Now when we turn on the artifact reduction, same story here. It removes that bad F8 electrode, but now we have some other things happening in our numeric display. We've added some parameters here. And again, this is a customization that can be done. So when I go to trend preferences, we can see where those are set up. Now this is under numeric panel. So what I've added here is I've got versus baseline, asymmetry, anterior, and posterior. Well, these are single values. Let's look at the trends that are creating those in a moment. But those are spectrograms, and we've used the sum values trying to get just the single values from that. We've got heart rate. We've added electrode artifact level. Well, electrode artifact is calculated as a value for all the electrodes being recorded. Where does that come from? That's the sum values trend as well. And these are all just picked directly from those particular trends, and they're being displayed over on the right. Now, when I click on this, I can set the upper limit. So if I said, well, I want 2 bad electrodes before you let me know for 5 minutes, you can see that goes back to green. So I can change the threshold and the duration either as a default value, or I can change that on the fly as I go. Let's go ahead and set this to 1. So you can decide the number of electrodes you'd like to have it find as being bad for that amount of time before it gives you some sort of indication, and you can set a notification for that. So where are those showing up, those notification trends? Now here we've got active notifications. And what an active notification trend panel does is it says, well, for anything I've got a notification set up for, show me a panel of just those. And that's where we can see the sum values, absolute for electrode signal quality. And over here I can see some values average for the versus baseline asymmetry. So let's take a look at the versus baseline asymmetry. And we're going to go ahead and pick that. So here we're looking at versus baseline quad FFT asymmetry. So these are just asymmetry spectrograms. We have a seizure here where the EEG becomes has an increasing level of asymmetry. And I've got a separate screencast that talks about those, but basically these are rendering z-scores. And increasing z-scores are rendered in red, decreasing z-scores below zero rather, negative z-scores are rendered in green. So this is an increase in z-scores from the baseline during that seizure, so this is turning red during these. And this is looking at left anterior, left posterior, right anterior, right posterior. So these are z-scores calculated from a baseline early in the recording and rendering those. Now what we have at the bottom though are asymmetry z-scores. So this is looking at the degree of asymmetry in positive or negative z-scores. Now these are rendered in increasingly green, whether it's going positive z-scores and negative z-scores, because asymmetry is just a value of what's the difference between homologous electrodes between left and right. And so with an asymmetry spectrogram, the important thing to keep in mind is that you can have an asymmetry happen because you have an increase in amplitude between homologous electrodes left and right, or a decrease in amplitude. And so it's more, you can think of it more of a balance beam or a balance scale, where it's tilting one way or the other. But the asymmetry relative spectrogram doesn't tell you which way it's tilting or why. In other words, a ratio trend doesn't have any amplitude information, which goes into another topic. I always like to put amplitude trends with any sort of ratio trend, whether it's alpha-delta ratio, relative alpha, or asymmetry. Those are all ratio trends. They don't include explicit amplitude information. But just the thing to keep in mind, though, is that we don't expect symmetry to change with state changes. Usually when symmetry changes, it's due to something else happening here because of a seizure. And if we go a little bit further along here, we have some postictal slowing after the seizure. So you can see that asymmetry spectrogram remains darker in color following the seizure. And just to get our bearings, let's go back to this one, where we have the seizure here. And then we have some postictal slowing. You can see that showing up in this relative spectrogram here, where we have red towards the top, indicating that we have a higher amplitude on the right at the faster frequencies and higher amplitude on the left at the slower frequencies, while the seizure was predominantly left. And then we lost faster frequencies on the left, which made the right larger in comparison. There's that phenomenon where asymmetry spectrograms, they're basically a ratio. You're looking at the amplitude between homologous electrodes at each frequency, going from 1 to 20 hertz in this case. Okay. So when we go back to that other trend, which is showing just versus baseline asymmetry, we can say, well, I want to know the statistical changes in symmetry going forward. And we can see there's a statistical change in symmetry showing up here. Well, how do we turn this into a single value? That shows up here. So here we have symmetry that's below our threshold. We set above 2.5 for our z-scores for more than 5 minutes. And then the seizure happened and it begins to go up and exceeds that threshold. We can see that threshold set here. Well, how do we turn that into that single value? So let's go ahead and look at this. This is our sum values for versus baseline asym anterior and posterior. So when I click on this, what this is using is the versus baseline asymmetry relative spectrogram for the anterior. And using absolute values, I don't want to take negative values and try to set thresholds for that. I want to turn everything into a positive value, but I want to use the entire range of values here. So here I'm going from 1 to 20 hertz. So each one of those is a z-score in those half hertz bins. So I've got 40 values here going from 1 to 20 hertz. How do I turn that into a single value? That's some values, turn them all into positive, but use the entire range from 1 to 20 hertz. So this is that -1 to -1 for all values. Here we have lower index, upper index set to -1 for both. And I'm using average values rather than adding them all together. And so you can see here, if we go back to an earlier part of the recording, let's navigate using our comprehensive trend panel. There's that seizure. Let's go to where they're awake. Eyes closed. There's the alpha there showing up in the trend. Let's go back to that versus baseline quad asymmetry. So here the values are lower. And then when that seizure happens, you can see they go up. What it's done is it says, all right, I'm going to take all the values for the spectrogram, turn it into a single average, and then display the average as a line trend. And with a line trend, you can set a threshold. That's it in a nutshell. All right, now let's look at signal quality and how we can trend that. So I'm going to go back to this other, and we'll look at my active notifications. So we've got a trend here looking at the sum values for our electrode signal quality. And so if we look at that, under other panels, we've got signal quality here. This is our signal quality display. And this is a standard one in persist. So you'll have this in your default set of trend panels. And what this is showing is artifact intensity for muscle, vertical eye, and lateral eye for all the channels. And the increasing color of this, as the color increases in darkness, you've got more of that artifact there. So here we can see the amount of artifact increasing here, and if we go here, we have less artifact. Let me turn off that artifact reduction so we can see it in the traces. So let's go forward to this part. Now F8, this becomes bad. So this one has exceeded the threshold, and it's turned red at this point. And so that sum values trend looks across all of these channels, regardless of how many channels they are. It automatically detects the number of 1020 channels. So if you've got 1020, or if you have 1020 with subtemporals added, the number of channels will change dynamically. It just reads the channel map from the incoming EEG, and now we have the sum values trend. But instead of averaging that, still looking at the entire index, which is however many channels you have here. We don't know how many 1020 or 1010 channels will appear in this, so it's however many channels they are. That's why it's -1 to -1. And I'm going to sum them. I'm not going to take the average, because I'm going to add for each bad electrode that shows up. And so we have one bad electrode here. This goes to 1. And if we can find some places where that has increased beyond that, let's turn this trend here. Let's look at 10 minutes. We're zooming in a little bit. We're looking for a place where this might go beyond that. Yeah, so 3. So here it's gone up even higher. So it's just the number of bars here that indicate that it has electrode artifact. And you can set this to whatever you want. So when I click on this, we get the thresholds here. I'm going to set the upper limit. Let's say you didn't want to be notified until 2 exhibited electrode artifact for 5 minutes. Go ahead and indicate that on the numeric display, place a comment, and you can set it to trigger notification through Persist Mobile and so forth. So that's how that works. You can use that to take trends which have lots of values. In this case, we've got a trend with lots of discrete values for individual electrodes, turn it into a single number. That's what happens down here. And then turn that into a trend that you can then use as a threshold, and then indicate when that threshold has been exceeded. Or let's shift to that other screen. You can use that sum values to pick off individual values, for instance, for an AEEG trend, and then you can input those into time trends and show parameters for AEEG. In the case of the spectrograms, use that -1 to 1 index. And in the case of AEEG trends, we'll go to trends, we'll go down to here, sum values. We're using 0, 0 for the max, 1-to-1 for the min. Again, I click edit here, sum values, we can see it's 1-to-1, saying just get that one value. How do I know it's that? Well, you can always contact us, but for AEG, again, AEG is pulling out 5 values for each epoch. Max, min, that's what gets rendered in this display. That's why it's so thick. You're getting the maximum value and the minimum value, and it colors in the entire expanse of that. But it also calculates median, 75 and 25%. Those aren't displayed. Why? Because when I click this and look at the output, it's set to min-max. I did that a little quick. Let me click on the trend properties for this, click on the output. It's showing min-max. So it's showing the entire excursion there. But again, all these values are available. But if I try to put that out and get a single value for it, that's what I use sum values for. Anyway, that's a rather long explanation, but any questions, I'm happy to connect. This is Michael Guest, VP of Research and Clinical Applications for Persist. Thank you.